Okay, a more slower version of those notes, if we could, and I'm going to leave them complete up here. You take your time on this, but we are doing, and this is 9-4, and it's because we are talking about similar triangles right now, a very specific similar triangle situation when dealing with right triangles. And then we'll clean this up on Thursday and talk about some other with triangles. If other things are drawn, what similarity situations happen. Okay, you just feel free to look at this. You gotta have the ability to cross multiply and solve. You have to have the ability in this section to simplify radicals. Just looking at this one real quick, 45 is 9 times 5. Square root of 9 is 3. So knowing how to simplify a radical, I know some of us still don't know how to do that. I remember our tests and I don't know what's going on. We just got to get it figured out or else it's going to keep getting us here. And then 72, what I first did is broke that down to 8 times 9 because I know my times tables. A big thing there too, being numerate. And then knowing 8 is 2 times 4. 4 is another perfect square. So then what I write below 72 is, oh, okay, 4 times 9 is 36. So 72 is 36 times 2. Got it. So now I can simplify this radical quite easily. Square root of 36 is 6. Not sure what people are missing and not still being able to do this. I don't know. I should have been coming in and getting this solidified and not being afraid of ugly ogre Mr. Samuelus. All right, and then I do want to rehash this, what is going on, and then I'll redraw this. And then, I think I did a really good job in third hour, yeah, both hours, but just talking about why these are and writing this down. So what's given first is this big triangle, and it's a right triangle. Remember, similar triangles, sides are proportional. That's really what these two theorems are based off of. When I drop a perpendicular from the right angle to the hypotenuse, or what's called an altitude, that is called an altitude, then what it does is creates two smaller right triangles as well. Now we have three right triangles from this one. And then what is true is all of these triangles are actually similar. And they're similar by AA. And I'll prove it real quick. It's very simple. The blue and the yellow, I guess I could put that. Yellow and the blue are similar by AA because they both share angle A. I mean, look at that. And angle A is congruent to angle A. And they both have right angles, and all right angles are congruent. So there we go. I've established that two angles and two separate triangles are congruent. So by AA, they are similar. And then also by AA, the yellow and the green. Let's do that. The yellow and the green triangles. Yeah, I most certainly hit that. Fake news. All right. So by AA, these are similar, and then very easy to prove that. It's because they both share angle B, and they both have a right angle. This is definitely a right angle here, although it seems kind of messy to write them both as right angles. That's why you usually only see one of the sides showing the right angle there. Okay, so by AA, the green and the yellow. And then by default, it's really what I think is by the transitive property, but you don't really have to know that. We used to really make geometry students remember all these things. The blue and the green must be similar as well. So if A is similar, let's just use letters that are not pertaining to this, but that's what the transitive property is. If X is similar to Y and Y is similar to Z, then X must be similar to Z. All right, and that's what really is. I hope I have it as a transitive property. It might be wrong. If we were in class, this is what I would do with this and to prove it. We'd take these little triangles and yank them out and then rotate them around. There's the big triangle. There's the one that was in the middle size, and then there's the tiny triangle. So that one on the right is the green one. The one on the left is the blue one. And then just proving that these are similar. And then therefore, if they're similar, we have sides that are proportional. Okay, so I kind of have this left here, my work for this. And then I'm just trying to make a cleaner version of this video for purposes of being online. So I'm going to use the term geometric mean a lot. I'm going to erase this and have it come back. Okay, the geometric mean is of two positive numbers, A and B, is a positive number such that this is true. So X is said to be the geometric mean between A and B, right? I just want to use that idea so that when we see it in our theorem, we know what geometric mean means. You could also switch these, and X over B certainly equals A over X. Reflexive property, I think. Oh, if I'm saying these wrong, if they're the wrong properties, math teacher could just come get me fired. I dealt with a math meeting this morning that made me ultimately depressed and sad. So I'm just kidding. It is tough though. But all right, so here's our first theorem. And then I'm going to go ahead and erase it, what we have here, and really not over explain this. But really, it is true, my little trick. So what this first one is, though, when I erase this stuff and then we could see these letters here. Oh boy, that's bad. Is comparing the two smaller triangles first, and I forgot who was what color. So this triangle is similar to this. That's what this first theorem, our little trick can be. So we don't have to pull the triangles apart and try to figure out who are the similar or proportional parts. Remember, triangles, the sides are proportional. That's why we have a couple of proportions here. So I'm going to go through this again. The measure of the altitude drawn to the hypotenuse, the altitude is the geometric mean. So this is the geo mean. You will see this in the geometric mean position that I just covered. This right here. By the way, what this drawing is missing, right angle, right angle. And it's the geometric mean between the two segments of the hypotenuse of the big triangle. So we'll do segm 1 and segm 2. Okay, and this is what I told my students on this. This is how this can work for a cheat. So what we can do when we're dealing with the altitude in this question, we could start on either side. We could start at this vertex, go this way, segment 1 over altitude equals, back down, lost my pen for some reason, altitude over segment 2. And that's what this represents in the segments that are listed there. Or we could start on the right for the trick for putting the correct things here. Starting at this vertex, go left, BD. I don't know why I'm losing my pen. Hey, I lose it every day. Over, oh, great. There we go, it's back. Over CD equals, pen halfway again, and pen halfway again, in, out, CD over segment 1 AD. All right, so this trick, you start on the left or the right, and you draw those arrows to write your proportion. So looking at our first question, I decided to go red. Look at the red equation. Okay, we're only going to do one at a time. So how do I know that this is the one we're going to use? Look at, we have the altitude and we have these two parts of the hypotenuse given. So the red equation, wrong. That's the blue equation starting over here. Starting at this vertex, 9 over x equals x over 4. That's the action that you use in order to write your proportions. The red is just starting with the left and then moving right from that vertex. So here's the red. 4 over x equals x over 9. You can keep it connected as far as your actions there and which way you're going, right, in order to write these proportions. A trick. But really it's because the smaller triangles are similar. That's why this is the case. Very simple on this one. Oh, pick left or right, left or right, left or right. Left. X over 8 equals 8 over 4. You never pick up your pen in both tricks. This trick, that's why it's only 4 that we have at the end there. Oh, this one's not as bad as all at all. 4x equals 8 times 8, 60. Oh, what is 4 times 16, I believe. And that's not a plus minus answer, so we don't have to worry about that. One thing about plus minuses, algebraically, yes, when you square root both sides, you get plus minus 6. Geometrically, there's no such thing as a negative side. So you should never say a negative on this. All right, I did that one, and then number 9 is just as simple. 9 over x equals x over 16. So I'll do that with a highlighter, never picking it up. 9 over x equals x over 16. That's the trick. If you can remember that, it's very simple. It's memorization. No plus minuses in geometry. The next ones, I did go through a little faster, is comparing. This is why I have 2 drawings for this. Comparing, and I kind of hurry up. No, not really. I got 5th hour coming up here. The next one is comparing the big triangle to one of the 2 smaller triangles and saying that those are similar. So the yellow triangle is similar to the blue triangle. Okay. So reading this statement, if the altitude is drawn to the hypotenuse of a right triangle, each leg of the right triangle, and they really should say the big one, the big yellow one. So each leg of the right triangle, gosh dog it, my pen just really is not activating right now. Sorry for swearing. Each leg of the right triangle, well, okay, which leg? Well, in this one, it's the leg on the left. This is the leg of the right triangle, the big one. I know we have 2 other right triangles. We're talking about the big right triangle. Is the geometric mean of the hypotenuse and the segment of the hypotenuse that is given in a particular situation. So this is blue to yellow. Then rereading this question again, each leg or the leg of the big right triangle is the geometric mean of the hypotenuse and the segment of the hypotenuse given. This is why we need 2 separate things. Who am I comparing, blue to yellow or green to yellow, or depending on what's given in the question? This one, you start in the middle. This is all you have to remember for the trick. Boom, going this way, AD over, now continue and go this way, AC. It really all depends about what's given, how we do these. You just have 2 things to separate in your brain. AC again, and there you go. The idea of geometric mean, AC is a leg of the big triangle, and it's a geometric mean. It's in that classic definition of what does it mean to be a geometric mean. Wow, a lot of word mean in there. Okay, and I didn't finish this. Okay, so where was I at? I went starting in the middle, left, up, down, all the way across on this one. That's why that arrow is still left over there. AB. Or starting in the middle, because this is the segments given, I go right, and that is DB over this leg as being the geometric mean. BC equals back down, BC over all the way across on this one, AB. You really got to be careful on what's given and when to do what. And then I'm not going to rewrite these examples. We can see it. Maybe I will. Maybe I'll get rid of the highlighting. No, not the highlighting. I'll get rid of my arrows and redo them. So how do I know when to use what? You know, I taught you the first thing. Well, there's no altitude given. There's nothing and there's no X on that. What we need to find is a leg. And that's why I have that. What the heck just happened here when I hit the back arrow? Yeah, okay. All right. But it flipped my page. So this one, we want to start in the middle because it's a leg that's given, not the altitude. Boom. That's the segment of the hypotenuse. 2 over x equals x, back down, over the whole hypotenuse. That's why you see that arrow there. So it is 8 that goes in that position. I had one like this where you just got to be careful. Okay, and I'll erase this, but this one's comparing the green to the yellow. Right, they got a lot of junk here, so maybe rewrite this here. Um, Breaking this down. Whoa, whoa. So you start in the middle and go right because of what's given. It's the segment to the right of that altitude point right there. Over x equals back down x over the whole hypotenuse. Oh, well, this one I have to just do a little adding. You just got to be careful. 24. Okay. And then when you cross multiply, I think I ended up getting 480. And then I don't want to, I think everyone was in class, but broke this down to be 16 times 30 in class. So that's up to you on your calculator. Beep, boop, beep, boop, beep, boop. Trying to find the perfect square. And I know 30 is not good because 3 times 10 is 3 times 2 times 5. 30 has no perfect squares hidden in it. Square root of 16, though, is 4. Now, algebra, geometry. Geometry is real world measures. So you drop the negative. Keep harping on this because if this is not tied to a geometry question, then you must have plus minus on that for correctness. Right, and then as we're finishing up here, just so I have an official video, what else did I start writing on here? I kind of skipped the word problems and went to the end here. So how do you know when to use which one? Okay, now this is just a smattering of questions like a quiz. Solve for x. Oh gosh, which one is it? What's the trick? Do I start on the side or do I start in the middle? And it all depends upon what's given. And that is not given. You're not finding anything about the altitude that's dropped in the big triangle. This is one where we start in the middle because this is the geometric mean. That's another way to understand when I say it's in the geometric mean position. When you're done, that's the geometric mean. So 24 over 14 root 6. Now, this just has some fancy root 6 in there. How do you deal with a root 6 kind of thing? Yeah, because of our shortened time together, we may not have a question like this, although it's not that bad. Really, it isn't. It really should be. It's a simple question that I would ask any regular student as well. But that would be the setup. The final move is the whole hypotenuse, which is these parts together. You don't multiply those two. You add those two together to get the full length. So a lot of people put 24x there. No, it's 24 plus x. Then you just have to cross multiply and solve. I wanted a little bit easier ones. I mean, this one's pretty easy. Why is it starting in the middle? Because I don't have the altitude. This is the geometric mean. Just like I said, 14 root 6 is the geometric mean. Look, classic definition of geometric mean. It gets multiplied by itself when it cross multiplies. This is another one of the second one. This is the only one of the first one. But it did become a little bit tricky. So why do I use the other one for this? That's because the altitude is given. So the altitude is the geometric mean. So where do I start on this one? On either end. But that means I need this segment. What is this when this is 64 and this whole thing is x? Well, if I told you the whole thing was 70 and this was 64, everyone could tell me that's 6 because all you have to do is take these and subtract them. So what this is in terms of x is x minus 64 because I do need that. Now this is a distractor because this one we start on either edge on our trick. We start at the left, or I'm sorry, my right, and move left. That's 64 over up the altitude, 8 root 17. Again, a complicated radical. Down the altitude. There you go. The altitude is the geometric mean. Boom, boom. Over, okay, hopefully you don't sweat it out too much that why that's x minus 64. It wasn't given, but given this whole length minus this length would be what that is. And that's all x is it represents a number. Okay. I feel like that's good. Feel pretty good about putting that as a video for those that need the extra.